Okay, how's it, Chase? As promised, I'm just going to do those questions that you asked me to do. So yeah, let's get cracking. So on the picture you sent me, it starts with question 4, and it says determine the limit as x tends to 2 of x minus 2 over x squared minus 8. Okay. So here it's quite a simple limit. All we're going to do is do some substitution and check what form or what answer we get. So if we substitute 2 in, we get equals 2 minus 2 over 2 squared minus 8 is equal to 0 over minus 4 is equal to 0. And there you go, there's your answer. Okay, then let's move on. Question 4.2 says, given y equals e to the 3x cos 3x, differentiate by using the product rule. So we know that the product rule is, I'm trying to think of yours, d by dx of uv, I'm just trying to write it in your notation, so please forgive me if it's wrong, equals du by dx times v plus dv by dx times u. I believe that's the formula. Let me just write it in my notation. So the derivative, f prime equals f prime g plus g prime f. Yeah, that is the product rule. Sorry, as I said, this, these things, if you don't use them regularly, you do tend to forget them. So I just want to double check before I do the question. I don't want to lie to you. So I just want to double check what the product rule is. I think I have it correct. Yes, u dv by dx plus v du by dx. Right, so that's easy. So if we assume that u equals e to the 3x, and we've got v equals cos of 3x, then du by dx is equal to 3e to the 3x, and dv by dx equals 3 cos 3x, okay, and therefore dy by dx is equal to, by the product rule, du by dx times v plus dv by dx times u, right? So du by dx is 3e to the 3x, so we just put 3e to the 3x times v, which was cos 3x, plus dv by dx, which is dv by dx is 3 cos 3x times u, which is e to the 3x. And there you go, there's your final answer. You could simplify it a bit further and write it as maybe, sorry about that. You could maybe write it as, I think I've selected something which I didn't mean to select here. Sorry about that. Okay, we could write it as, we take out an e to the 3x and we write it as 3 cos 3 did these two come out the same? Yeah, so 3 cos 3x plus 3 cos 3x. This one actually simplifies quite nicely because it becomes 6e to the 3x cos 3x. Okay, so that's question 4.2. Let's move on to question 4.3. Alrighty, 4.3. Okay. Differentiate the following with respect to x. So basically find d by dx, or dy by dx. Okay, so the function is given as y is equal to... Hello, Dad? Yeah. Okay, sorry about that. My dad just called me. So, let's carry on with this differentiation. 2 times 3 to the 3x, I think. 3x minus 4 cos 2x minus 5 ln of x minus 3 to the x minus 1. 3x to the minus 1, sorry. Okay, differentiate with respect to x. So, we can differentiate each term separately. Then we're going to have dy by dx equals d by dx of 2 times 3 to the 3x minus 4 d by dx of cos 2x I'm sorry, I just realized now I made a massive mistake here. That's not cos 3x. Derivative dv by dx, the derivative of cos is minus sine. Sorry. So this is going to be minus 3 sine. Sorry, that's my mistake there. It was a bit of a stupid mistake. That's what happens when you're not thinking properly. But yeah, there you go. I think the rest is correct. Sorry about that. Okay, anyway, carrying on with this. Cos x minus 5 d by dx of ln x minus 3 d by dx of x to the minus 1. Okay, and let's start differentiating. So the derivative of our first is 2 times the derivative of 3 to the 3x is 3 times 3 to the 3x ln 3x, I believe. Derivative of a to the x is a to the x ln a. Yeah, so there you go. Minus 4 times the derivative of cos 2x is minus 2 sine 2x minus 5, the derivative of ln x is 1 over x minus 3, the derivative of this is minus x to the minus 2. Okay, so our final answer is going to be 6 times 3 to the 3x ln 3x plus 8 sine 2x minus 5 over x plus 3x to the minus 2. And there's your final answer for 4.3. Okay, let's move on to 4.4. Okay. 4.4. Given y equals x cubed minus 11x squared plus 32x minus 28. Determine using differentiation the maximum and minimum turning points. Also determine the point of inflection. Okay, so the maximum and minimum turning points. Okay, so let's take dy by dx. dy by dx is equal to 3x squared minus 22x plus 32. 32. Okay, let's also just take the second derivative so long. Sorry, my pen just freaked out there completely. Okay, d squared y by dx squared. So our second derivative is just the derivative of this function, which is 6x minus 22. Okay, so how do we find our turning points? Well, so to get our turning points, we just let dy by dx equal 0. Okay, so 3x squared minus 22x plus 32 equals 0. Okay, and then we just solve this equation. Now I wonder, I don't have my calculator on me, so I hope this can be factorized. Doesn't look like it. So let me just go grab my calculator and make our lives easier. Okay, so I'm going to be lazy here and use my calculator to solve this quadratic equation. So on my calculator I press mode, equation, then I press number 3, which is the quadratic, and then I just enter my coefficients, which are 3, minus 22, and 32, and I'm going to solve that. Obviously, you would use your x1, x2 equals negative b plus or minus the square root of b squared minus 4ac over 2a. That's the formula you would be using if you don't have the calculator, but in any case, our roots are x equals 5,33 or x equals 2. Okay, so those are our roots there, nice and easy. Then we've just got to get our corresponding y points, and how do we get that? We're going to substitute these x values back into this equation over here. So we're going to substitute y equals 5,33 cubed minus 11 times 5,33 squared, etc. So we just substitute in, and we get that y is equal to, let me just pop it into my calculator here, 5.33 cubed minus 11 times 5.33 squared plus 32 times 5.33 minus 28, and our corresponding y point is minus 18,51, and if we substitute x equals 2 in, we get 2 cubed minus 11 times 2 squared plus 32 times 2 minus 28, which is 0. So here we get y equals 0. Okay, so we've got our two turning points, which are 5,33 and minus 18,51, and 2 and 0. So which one is our maximum? If we look at the y point, this is our max turning point, and this is our min turning point. Okay. Alright, they say also determine the point of inflection using the second derivative. So for point of inflection, let d squared y by dx squared equals 0. Therefore, 6x minus 22 equals 0. X equals 22 over 6. X equals 22 divided by 6 is 3,67. Okay. Then we're going to substitute in our y value. Or we're going to substitute this x value into our original function to get the corresponding y value. So I'm just going to pop it into my calculator. I'm not going to write it out. So our y value is equal to, where's our original function now? I can't see it right now. There. So 3.67 cubed minus 11 times 3.67 squared plus 32 times 3.67 minus 28. Okay? Our answer is minus 9,29. So here our point of inflection is, we just write it as an ordered pair, 3,67 and minus 9,27. And there you go, there's your point of inflection. Okay, I'm going to stop this video here and then I'm going to continue with the second half, the question 5 section. I'm going to continue with that in a few minutes. So thanks for watching, I hope it helped. I hope everything is right. As usual, if you've got any questions, if you think I've made any mistakes, whatever, just let me know, or any more questions on this work, whatever, and let me know and we'll see if we can sort it out. Cool man, cheers.